Hello friends, so welcome to lecture series on multivariable calculus. In the last lecture we have seen that what do we mean by a function of several variables, domain and range of two or more than two variable functions, whether region is open, closed, bounded or unbounded. All these things we have seen in the last lecture. Now how can we find limit of multivariable functions? Okay. So we recall it. First we recall for limits for one variable functions. So suppose we have limit x tending to a f(x) is equals to L. So what does it mean? It means that as x approaches to a, f(x) approaches to L. So roughly speaking, when we say that limit x tend to a f(x) equals to L, this means as x tending to a, f(x) tends to L. Now how can we define this mathematically? So the mathematical definition of limit is, for every epsilon greater than 0, there exists a corresponding real number delta greater than 0 such that mod f(x) minus L less than epsilon whenever 0 less than mod x minus a less than delta. You take any epsilon greater than 0, no matter how small, how large epsilon you are taking, there will always exist a corresponding delta greater than 0 such that f(x) minus L, the mod of this, less than epsilon whenever this quantity less than delta greater than 0. Or we can say that this implies mod of f(x) minus L less than epsilon. Now what does it mean? What does this definition mean? Now let us see. Now here we are having that limit x tending to a f(x) is equals to L. This means for every epsilon greater than 0, there exists corresponding delta greater than 0 such that mod f(x) minus L less than epsilon whenever 0 less than mod x minus a less than delta. Now this means that x minus a is less than delta greater than minus delta, okay, and this means that x is less than a plus delta and greater than delta minus delta plus a, and of course x should not equal to a, because if x equal to a then it is equal to 0 and x should not equal to a. This sometimes we call as deleted neighborhood. This we are also called as a deleted neighborhood of x at a. Now similarly what this means, what this inequality represent, this is f(x) minus L less than epsilon greater than minus epsilon, or f(x) is less than L plus epsilon and greater than L minus epsilon. So this means, now this is suppose L, this is f(x) equal to L, okay. Now this is suppose L minus epsilon and this is suppose L plus epsilon. Okay. Now, x is between a minus delta to a plus delta. You take, suppose this is x equal to a, suppose this is a minus delta and this is suppose a plus delta. Now, this definition means, this means you take any epsilon greater than 0, no matter how small, how large epsilon you are taking, there will always exist a delta such that the image of all those x lying in this interval will always be contained in this band. Will always be contained in this band. Means you take any epsilon greater than 0, no matter how small, how large you are taking, there will always exist a corresponding delta such that image of all those x lying in this interval will always be contained in this band. Now, if you take epsilon very small tending to 0, then this delta will tend into 0. That means that as x approaches to a, f(x) will approach to L, because as epsilon tend to 0, this will tends to L, and as delta tend to 0, this will tends to a. So, as x tend to a, f(x) will tends to L. Okay. So we can say that f of all those a minus delta to a plus delta, this all those x lying in this interval, okay, will be contained in L minus epsilon to L plus epsilon. So, that means for every epsilon greater than 0, there will exist a deleted neighborhood of x at a such that the image of all those x lying in this interval will be contained in totally inside this band, totally inside this interval. Okay. So, this is how we can define limit of single variable functions. Okay. Now, let us first discuss few examples based on this. For example, limit x tending to 2, 2x plus 4, 2x plus 1 is equals to 5. This is very simple. One can easily see that limit of this simple function 2x plus 1 is x into 2 is 5. How can we prove this using delta epsilon definition? So, let us see how can we prove. So let epsilon greater than 0 be given. You take any epsilon greater than 0, you take some epsilon greater than 0, okay. The same process will repeat for any epsilon greater than 0. So, we can say that for every epsilon greater than 0, there will exist some delta. So, basically what we have to show? We have to show that for you take any epsilon greater than 0, there will always exist corresponding delta such that that definition holds. What we have to prove basically, that for every epsilon greater than 0, there will exist a corresponding delta greater than 0 such that mod of 2x plus 1 minus 5, this is f(x) minus L less than epsilon, less than epsilon whenever 0 less than mod x minus 1 less than delta. So, basically mod x minus 2 less than delta. Okay. So, basically we have to show the correspondence of delta in terms of epsilon. We have to show the existence of delta. Okay. So, how can we do that? Now, we start with this inequality. Okay. This is mod 2x plus 1 minus 5. This is equals to mod 2x minus 4. Okay. This is equals to mod 2x minus 2. This is equals to 2 mod x minus 2. Okay. And this is equals to, if this is less than delta, so this is less than delta. Now, this quantity, this is less than 2 delta, because this quantity is less than delta. Now, if we choose 2 delta less than equals to epsilon, then mod of 2x plus 1 minus 5 less than epsilon whenever 0 less than mod x minus 2 less than delta. Now, this is because whenever you choose delta less than equal to epsilon by 2, then this inequality always holds, because this is less than 2 delta, which is less than equal to epsilon. Okay. So, that means this is less than epsilon whenever this is less than delta. So, this inequality always holds whenever delta is less than equal to epsilon by 2. You choose any delta greater than 0, you can choose any epsilon greater than 0, you can always find delta which is less than equal to epsilon by 2, for which this inequality holds. So, we have shown the existence of delta in terms of epsilon. For different epsilon, delta will be different, okay, but we have shown the existence of delta in terms of epsilon such that this inequality hold. Hence, we can say that this limit exists and is equal to 5. Okay. So, this is how, using delta epsilon definition, we can show that the existence of a limit of a function. Now, same concept we extend for 2 variable functions. Okay. Now, how can we do that? Let us see. Now, we say that for 2 variable functions, we say that f approaches the limit L as x y approaches to x naught y naught if the values of x y values of f x y lie arbitrarily close to a fixed real numbers L for every x y that are sufficiently close to x naught y naught. You take any x y that are sufficiently close to x naught y naught, f x will arbitrarily close to L. That means, f x will approach to L as x y is approaches to x naught y naught, x y is arbitrarily close to x naught y naught. How can we define this in terms of delta epsilon? Let us see. Now, here we are having 2 variable functions instead of a single variable function. Now, in single variable function, say we have a x equal to a. So, when we take disk at this point at x equal to a, so this will be an interval, it is a minus delta to a plus delta, this is an interval. Now, when we take point in 2 variable, a function of 2 variable, okay, say here x naught y naught. Now, instead of an interval, it will be a disk centered at this point, okay, it will be a disk centered at x naught y naught. So, how can I define limit now? Now, limit x y tending to x naught y naught f x y is equals to L. So, how can we prove whether limit exists and is equal to L? So, for that again we will repeat the same definition for 2 variable functions. For all epsilon greater than 0, there exists a corresponding real number delta greater than 0 such that mod f x minus f x y minus L less than epsilon whenever 0 less than under root x minus x naught whole square, okay, plus y minus y naught whole square less than delta. So, you take any epsilon greater than 0, there will always exist a corresponding real number delta greater than 0 such that this inequality hold whenever this is less than delta or greater than 0. So, this is a dilated neighborhood of x naught y naught of radius delta. So, this is basically a circle radius delta. Okay. Now again, what does it mean? It means that now this inequality means that fxy is less than L plus epsilon to L minus epsilon, and this means all xy that lies inside the region, inside a disk of radius delta and center x naught y naught. Okay. That means this region, center x naught y naught and radius delta, this region, and this means this is L minus epsilon and this is L plus epsilon and this is some L. Okay. Now, you choose any epsilon greater than 0, you choose any epsilon greater than 0, there will always exist a corresponding delta such that all those xy which lie in this disk, the image of all those xy which lying in this disk will lies totally in this band, will lie totally inside this band. No matter how small epsilon or how large epsilon you are taking, there will always exist a corresponding delta such that the image of all those xy lying in this disk will totally contain in this band. Okay. So, as epsilon tending to 0, this will tends to L and this will tends to x naught y naught. Okay. So, this is how we can define limit for two variable functions. Now, since mod of x minus x naught is always less than equals to under root x minus x naught whole square plus y minus y naught whole square, because this is always true. So, this definition can also be written as mod f x y minus L less than epsilon whenever 0 less than mod x minus x naught less than delta and 0 less than mod y minus y naught less than delta. That means, instead of disk it may be a rectangle. Okay. Instead of disk it may be a rectangle. Then also we can apply the same definition. Now let us discuss few examples based on this, so that the concept of limit will be more clear. First, we have some properties of limit. Now, suppose limit x y tend to x naught y naught f x y is L and limit x y tend to x naught y naught g x y is L M. Then the addition and subtraction of f x y and g x y, limit x y tend to x naught y naught is L plus minus M. And similarly, we have the product of two functions, then the limit will also be product. Then scalar multiplication will be k into L, division by a f upon g will be simply L upon m should not equal to 0, and similarly we have the next property. These are very straightforward. Now, come to problems based on delta epsilon definition. Using delta epsilon definition, show that this is equal to this. The first problem, it is limit x y tending to 1 comma 2 2x plus y is equal to 4. So, how can we prove it? Otherwise, it is very simple. You see, when you substitute x equal to 1 and y equal to 2, the value is 2 plus 2, which is 4. Now, if somebody asks how can we prove mathematically that this limit exists and is equal to 4, so we have the only option is delta epsilon definition. We can use delta epsilon definition to show that this limit exists and equal to 4. How can we proceed? For that, we let epsilon greater than 0 be given. Okay. Now, again we have to show the correspondence of a delta, corresponding delta greater than 0, such that we have to show that there exists a corresponding delta greater than 0 such that mod 2x plus y less than 4 less than epsilon whenever 0 less than under root x minus 1 whole square plus y minus 2 whole square less than delta, or mod 2x plus y minus 4 less than epsilon whenever 0 less than mod x minus 1 less than delta and 0 less than mod y minus 2 less than delta. So, we can use any definition either this or this to prove this result. Okay. Now you take mod 2x plus y minus 4. This is equals to mod of 2 into x minus 1 plus y minus 2. You can easily see that it is 2x plus y, which is 2x plus y, minus 2 is minus 4. Okay. Now this is less than or equals to mod of 2x minus 2 x minus 1 plus mod of y minus 2, because mod of a plus b is less than or equals to mod a plus mod b. Now this is equal to 2 times mod x minus 1 plus y minus 2. Now mod x minus 1, so it will be better if you apply this definition, because this is direct, okay, for this particular problem. Now mod x minus 1 is less than delta if you take, so this is less than 2 delta and this is again delta, which is 3 delta. So if we choose or if we take 3 delta less than equal to epsilon, then mod of 2x plus y minus 4 less than epsilon whenever 0 less than mod x minus 1 less than delta and 0 less than mod y minus 2 less than delta. Okay. If we choose 3 delta less than equal to epsilon, then this quantity will be less than epsilon, and whenever this is less than delta and this is less than delta. So this inequality holds if this delta is less than equal to epsilon by 3. So for any epsilon, we have shown the corresponding delta, existence of corresponding delta such that this inequality holds. Hence we can say that this limit exists and is equal to 4. Okay. So the next example now, limit now let us discuss this example. Now here it is basically a 0 by 0 form. So it is very difficult to say whether this limit exists or not. Okay. Again, if this limit exists, so we have to show this by delta epsilon definition. That means we have to show the existence of delta corresponding to every epsilon greater than 0. So how can we proceed? We have suppose this limit exists and we have to show the existence of this limit. So let epsilon greater than 0 be given. Okay. Now you take xy upon under root x square plus y square. Okay. So this is equals to mod of xy upon under root x square plus y square. Okay. Now we know that x minus y whole square is always getting equal to 0. So x square plus y square minus 2xy is always getting equal to 0. So xy will always be less than or equals to x square plus y square by 2. So mod of this quantity will also be less than or equals to x square plus y square by 2. So this is less than or equals to 1 by 2 x square plus y square upon under root x square plus y square. So this is equals to under root x square plus y square upon 2. Okay. Now what we have to show here? Here we have to show that xy upon under root x square minus y square plus y square minus 0 will be less than epsilon whenever whenever 0 less than under root x square plus y square less than delta. So this quantity will be less than delta by 2. So if we choose delta by 2 less than equal to epsilon, then mod of xy upon under root x square plus y square will be less than epsilon whenever 0 less than under root x square plus y square less than delta. So if you take any delta satisfying this inequality, so this inequality will be satisfied. So we have shown the existence of delta corresponding to any epsilon such that this inequality holds. So hence we can say that this limit exists and is equal to 0. Okay. So in this way we can prove that using delta epsilon definition that the limit of 2 or more than 2 variable function exists and is equal to L. Okay. Now we will see some more properties of limit of several variable functions in the next lecture. So thank you very much.